Oh, I thought earphone it is. Good morning, everyone. Good morning. Good morning. Am I audible? Voice clear? Good morning, Deepika. Good morning, Kirti. Good morning, Surya. Very good morning. I think board is also fine. No, normal it is. No high brightness. Okay, fine. So how are you people? How everything is going on at home? Yesterday's exam, how it was? Are you preparing well as per your commitment, which you have showed for being a long-term student? That's the point I can raise for you. Think about it. What's the score you got, Kirti? Deepika, good morning, Durga Prasad. Hari Surya, good morning. What's the score you got yesterday exam, chemistry? 150. Why Durga Prasad, yaar? Why not 165? Pace exam. Deepika, Kirti, Hari Surya, your scores, chemistry. Vishesh, good, we are good, but keep on trying. Deepika 125, Zameen Sheikh Assalam alaikum assalam, beta. Tell me about the marks, because ultimate thing is you are at home. If you are working regularly, consistently, improvement has to be there, because selection is the main criteria. Very good, Jyoti, good marks, but keep on working. Keep on working. In pace you can extend. In pace exam. Because in space, what happens? It's a combination of multiple pace. Now that's why it is important for you that you try to score maximize in pace. Then your confidence level will be high. That yes, I am doing the weekly portion in a very good manner. Then it will be replicated in the space exam or face exam. Gaming Telugu 114, yeah, less marks I can say. But yes, if you are getting 100 marks, you are getting 114. Okay, fine. Zamir, okay, 152, still good marks for Sajid. Why 161? Yeah, you people are responding in class. At least 170 above for you. Blessy, good morning. Getting it. Always set your targets. Arey, good morning, good afternoon, no problem. 156, Vijay. Vijay, in class do you respond here? Why less marks? Why not 170 above for you? Vijay, Mudi Vedu. What's the reason you are getting less marks? Think yourself now. You have to do paper analysis. Every paper by the evening time, when answer keys are there, analyze the paper. Mention a proper, maintain a notebook, paper analysis notebook it is. Maintain that question, why wrong? 156 question number, suppose wrong. Reason write down. So mention the reason there. I'm not reading the question properly, yaar. You have to read the question properly in exam or not. Will you take this chance? No. Mention such remarks. Even if it is silly, it is no more silly in final exam. Vijay, okay, good morning. Good morning, Kavita. Srinu, Binayak, okay, 157, good, good, but keep on doing it. If last time also getting 150 around, this time 160 above, 170 above. Pace is a possibility. Every student maintain this notebook. How many of you are maintaining the paper analysis notebook? You can say where you are maintaining pace exam analysis, question which is wrong, mentioning it. Naveed, good afternoon. Vijay is maintaining, very good, Vijay, but keep on writing the remarks properly. It's not about only getting which is wrong. You have to mention that question wrong. Then you can do what? Then you can mention the remarks that this is the reason for wrong. I will revise that concept. In the group, I can say, yeah, but I don't know who is maintaining that. We can say them every time. Say, what's the problem? I don't know for that. So group may, but maybe you download the paper or not from the net, from the app. It is NTA app, no? Okay, students. So shall we start today? Our part is MOT. Why don't you talk to them directly? That's the better way, na? Because every time I say, okay, we'll do. Okay, Storm Gaming. Arey, keep your name changed, yeah. Change your name. Go to the settings, find out how to change. Gaming Flow Telugu. What is written? Okay, you maintain a notebook. Everyone try to maintain a notebook separately for paper analysis. It will be very useful. Why? Before every test, you have to read it. You are not just maintaining it. Before the test on Saturday, you read your remarks generally what mistakes you are doing. Before face exam, you can see those face exams, which concepts you have done wrong. Physics also, chemistry also, bio also, like this. ठीक है, चलो start करें. बोलो बोलो. ठीक है. Last class में which part we have done? In last lecture, which part it was done? That is bond order. Yes, bond order. I said up to this part, I think. No? Up to this part completed. Configuration over. Case 1, case 2. One is O2, F2 and their ions. Other one is up to nitrogen and its ions. Yes, yes. Tell fast. I think some lag is there. Na? बताओ भाई बताओ. Up to last class we have done case 1, case 2 or bond order also discussed. Then configurations we have to write today. Check your notes and tell up to which part exactly it was done. Case 2 completed. Okay, case 2 completed. Configuration we have written. Case 1, 2 written. Okay, we have done up to this part. Up to this we have done. Yes, up to this we have done. Have you gone through it? ठीक है. That experimentally they have decided that for up to oxygen one case and for nitrogen there is another case. Clearly we know by the experimental results that is the following part. Then the reason is what? Reason is that we have done two cases last class. We have done two cases. We have done case 1. ठीक है ना? For O2, F2 and their ions. ठीक है? For O2, F2 and their ions. Configuration is there. And other case is case 2. For Li2, B2, C2 and N2 and their ions. ठीक है, that cases we have discussed. In this case, normal configuration was there, है ना? In which sigma 2pz, remaining portion same, sigma 2pz is less in energy than pi 2px, pi 2py. ठीक है. Now what is the meaning of sp mixing? Understand the meaning and learning to already we have done the cases. ठीक है. Now listen to it carefully. What happens? Up to nitrogen, it is considered that between 2s and 2p level, or 2s between 2s and 2p orbitals, energy difference is less. Up to which case? Up to nitrogen. The energy difference between 2s and 2p orbital is less. So what happens? they undergo a interaction. They undergo interaction which is termed as intermixing of s and p orbital takes place. 2s combining with 2pz, or general term 2s and 2p intermixing. Because of that intermixing, what is observed finally, experimentally, that up to nitrogen, due to sp mixing, due to 2s and 2p mixing, due to 2s 2p mixing, sigma 2pz becomes greater than pi 2px and pi 2py. So this is the point, that is the case, that here up to nitrogen energy level difference is less. Energy level difference is less. So that is the case with which one? 2s 2p orbital mixing. When it is undergoing hybridization, you can say, or standard language is intermixing takes place, then experimentally it is observed sigma 2pz is more than finally which one? Pi 2px, pi 2. Remaining order we write same, energy levels are affected, but order remains same remaining. Then after nitrogen, the order is normal, which is sigma 2pz is less than pi 2px, pi 2py. Why not mixing taking place in O2 and F2? Reason is they are high electronegative elements. So 2 energy difference in O2 and F2 are more. 2s is more closer to the nucleus in case of oxygen and fluorine. 2p energy level difference is more, hence there is no sp mixing, in which case O2, F2 and their ions. So that reason might be you forget, but remember the term s and p mixing. Okay? For hydrogen, though, there are only 2 electrons, so why we use the 2p there? It is only filled up to where? Sigma 1s2, sigma star 1s2, hypo in the. Okay, Samir? So it is not applicable where? Hydrogen and helium, but with Li2, then we can apply that concept. Although we are not going to fill there, filling will be later on, but up to nitrogen the gap is less, 2s 2p. Hence it is considered sigma 2pz affected and more in energy than pi 2px, pi 2py. For O2 and F2 the energy gap is more, mixing does not takes place, hence sigma is less in energy as compared to pi 2px, pi 2py. Clear this part? Where it is given in NCERT, you will get in the table. Last class maybe I have shown that table or not. Now we'll see. You can observe here stability, bond order given, then here, there. Here see, they have directly used this term. Here. With 2s 2p mixing, without 2s 2p mixing. You can underline this term in NCERT table. Up from O2, F2, Ne2, there is no intermixing observed. For up to nitrogen, intermixing is taking place. Okay? So only it is written in the orbitals here. Energy, no need to learn. No need to learn the energy values. Okay, now we talk about which part? Configurations are there before going further. Okay, अब देखो. In NCERT, when you go through this part, what is given? Bond order. Bond order formula underline. You all know generally, but still mark it. 1/2 Nb minus Na, which is number of electrons in bonding minus anti-bonding by 2. Then these two lines you can mark. When the molecule is considered to be stable, when number of electrons in bonding molecular orbital is more as compared to anti-bonding. Then molecule unstable if Nb is less than Na. Okay. Then next page you can, on the next column, here you can underline, third line. Positive bond order means stable molecule. Negative or zero bond order means unstable molecule. Underline किया ये, these three lines. Then magnetic nature में, diamagnetic substance, if there is no unpaired electron, it is diamagnetic. And if contains unpaired electron in the orbital, it is paramagnetic substance. Okay, up to this part underlined. Now in the notes we will write firstly the bond order, then we can talk about the other things. Bond order. Bond order is number of electrons in bonding minus number of electrons in anti-bonding by 2. ठीक है, Nb minus Na upon 2. Other part, bond order is positive, or if bond order is positive, molecule is stable, or stable molecule it is. Second, bond order is negative or zero. Bond order is negative or zero, unstable molecule. Unstable molecule and does not exist. Clear? So when we find the bond order, we will talk about it. If bond order is zero, it is not going to exist. Bond order negative, although in our cases, we are not going to use the term negative anywhere. But in NCERT, this line is given, so it is useful that bond order can be negative, can be positive, can be zero, can be fractional, all possible. But which is stable? It is greater than zero or positive. This is stable. We can consider as per MOT. If it is zero or negative, that is considered to be unstable molecule or ion. आई बात समझ में? Bond order formula clear? Bonding minus anti-bonding by 2. So now I am going to start writing which part? Electronic configuration. Yeah, it can be fractional also. Positive you can directly say. If it is positive, it is stable. Bond order can be zero, negative, fractional, positive. ठीक है, start करें अब. ठीक है, then we also talk about the magnetic nature. When we write the configuration, then unpaired electrons are there, that will be paramagnetic. If all electrons are paired up, it will be diamagnetic. Starting with the configuration firstly, which one? H2. Write down electronic configuration for H2. Then comment on its bond order as well as its magnetic nature. How many electrons? Hydrogen 2. Configuration sigma 1s2. Yes, sigma 1s2 means what? Bond order. Only bonding electrons are there. 2 by 2. 1. Bond order is 1. In this orbital 1s, how many electrons are there? 2. That is paired up only. That means it is diamagnetic. Sigma 1s2 means orbital is fully occupied. There is no unpaired electron, hence it is diamagnetic. Getting it? Same way. Keep on writing up to neon, Ne2. Helium 2, He2 configuration. Firstly, which is filled? Sigma 1s2. Then which orbital will be filled? Sigma star 1s2. 4 electrons completely filled. Bond order will be 0. Bond order 0 matlab unstable molecule. That means it will not exist. ठीक है? What's the configuration? Sigma 1s2, sigma star 1s2. Will it be diamagnetic or paramagnetic? Let's see how many getting the correct answer. Diamagnetic or paramagnetic? Storm Gaming, Dia. Blessy saying Dia. Okay, Sajid got the point. Kavita saying Dia. Vishesh saying Dia. Vijay saying Dia. My dear students, this molecule does not exist. If you are saying does not exist, that means how can we say dia and para? So with the intensity I asked and you responded. Very good. Those who responded initially, Durga Prasad does not. Okay. Answer removing answer. Shravan Kumar. Okay. Naveed removed. Message retract. What is this? Storm giving. Zamir got the correct one and Sajid also said initially correct and does not exist. Yeah, you have to be alert, na? Harish Surya. Yes. Good. Beta. Good. Okay. Now Li2. Write down the configuration. Before I write, your answer has to be there. Sigma 1s2, sigma star 1s2, then sigma 2s2. 6 electrons filled. Bond order will be 2 bonding, 2 anti-bonding cancelled. That is another way you can mark. Then how many left? 2 bonding. 2 by 2, 1. Or you can count total. How many total bonding? 4. Total anti-bonding 2. 4 minus 2 by 2, 1. Is it para or dia? No unpaired electron. It is diamagnetic. बोलो यहाँ तक कोई भी doubt up to third, but you have to reach up to Ne2. You have to reach up to Ne2. Any doubts up to third? Right for Be2. Unstable. Very good. Be2 when you write sigma 1s2, sigma star 1s2. 4 electrons gone. Next is sigma 2s2, sigma star 2s2. Bonding, anti-bonding same cancelled. Bonding, anti-bonding cancelled. Bond order is 0. Bond order 0, unstable molecule. Does not exist. ठीक है? Getting it? Same way, try to write for B2. B2 is important. Information is there. Write down for B2, C2. Up to 4, any question you want to ask. Up to 4th. Return. In B2, which configuration followed? Case 2. Sigma 2pz more in energy than pi 2px, pi 2py. So, KK means sigma 1s2, sigma star 1s2 cancel. Sigma 2s2, sigma star 2s2 cancelled. Bonding, anti-bonding. So, what is left out? How many bonding? Pi 2px1, pi 2py1 means 2 by 2. bond order is 1. Unpaired electron, that is paramagnetic substance. Up to this getting it? Now here observe. Bonding anti-bonding cancelled, bonding anti-bonding cancelled. Last electron in which orbital in bonding? Pi orbital. Last electron in pi orbital, and bond order 1 means one bond is there, and that to which bond it is? Pi bond. So here B2 or in B2, one pi bond is there, or one pi bond is present. Okay, getting it? So in NCRT it is not given, it is given for C2, but for B2 also one bond, because bond order is 1, and that to which one? It is one pi bond, because B2 does not exist in solid, it is in the vapor phase only, and MOT can explain it. Same way C2, configuration KK, sigma 2s2, sigma star 2s2, pi 2p x 2 equal to pi 2p by 2. Now tell, bond order outermost how many? 4 by 2, 2. So bond order is 2. Diamagnetic, yes, very good, diamagnetic. And in C2, 2 pi bond exist. And C2 exists in which phase? Vapor phase. C2 exists in which phase? Vapor phase. ठीक है? Getting it? So when you read the NCRT part, you will underline C2 case, specifically mentioned there. After class, read it, underline the paragraph given for C2. By up to C2, any doubts you have, up to C2. Every student, listen carefully and tell if you have any doubts up to C2. Up to C2. बोलो. Up to C2. अरे भाई remaining students, पक्का? No doubts? Then N2, configuration KK, sigma 2s2, sigma star 2s2. Now pi 2p x2 equal to pi 2p y2, and then sigma 2p z2. Bond order cancelled. These are 6 by 2, 3. Para or diamagnetic. Then next part, normal bond. 6 are there, 1 sigma and 2 pi bonds, normal case. 1 sigma, 2 pi, normal case. Which are important cases in this configuration? One is B2, one is C2, other is O2. So up to N2 we have done the case 2. Now up after N2. 16, try to write the configuration. Important case O2, then F2, and last is NE2. Return configuration O2 will be what? Change in the order. Sigma 2p Z2, pi 2p X2, pi 2p Y2. Then it is pi star 2p X1, pi star 2p Y1. Getting it? So bond order will be 2. 2 bonds are there. Bonding, anti-bonding, bonding, anti-cancelled. Here, how many? 6. And how many anti-bonding? 2. 6 minus 4, 2. 2 by 2, 2. Bond order 2. And important information is O2 is paramagnetic. By which theory it is explained? By molecular orbital theory, because it was known experimentally that O2 is deflected or O2 is behaving like paramagnetic substance. But theoretically by VBT or VACPR we were unable to explain. So MOT explained it that yes, it contains unpaired electrons in which orbital? Pi star 2px and pi star 2py, paramagnetic. F2 will be what? Diamagnetic. So configuration you can write for F2, pi star 2px, 2 pi star 2py2. I am not writing configuration. Directly going for bond order will be 1 and it is diamagnetic. You will write completely. Ne2 configuration you will write pi sigma star 2p Z2 and bond order will be 0, unstable. Okay. So these are the particular molecules, homodiatomic molecules with their bond order and magnetic nature. Return. Bolo, up to this point, up to this part, any question you want to ask? Up to this part, any questions from your side? We have completed as per NCERT the portion which is given for homodiatomic. Some other portions we are going to discuss now, some ions. Any questions? ठीक है, वेरी गुड. पक्का आ गया समझ में? अब देखो, as per NCERT NEET level, lot of time questions are there from MOT. The moment it's a diatomic molecule, it is from which model? MOT model. ठीक है? Bond length, bond order, stability, all for diatomic. Quickly recall, it's a MOT theory, right? Now, generalized term we can use here because we have to solve as per the test syllabus. Na? Our boundaries are limited. So we have to think in exam how to do this part fast. Firstly, I should understand the configuration. Why? Suppose in case question is given that how many anti-bonding electrons are there. So without writing the configuration, you won't understand. ठीक है? लेकिन if they have asked question on the stability, bond order, bond length, then I can directly go for bond order. By which way? A simple way that generally works here. Generally, not every time, but as per NCERT level, NEET level, it will work. That if number of electrons are how much? 14. Then what is the bond order we have done for nitrogen? It is 3. learn it already, na? This we have learned. So whatever we are going above and below, keep on reducing by 0.5, 0.5. If 13 electron system, you will say reduce 0.5. That is a theoretical way. Understand one thing. Is it it is already always possible for every example? No. Where it will go outside, but that is beyond the NCRT part. So that's why play within the NCRT part. 12 electron system, reduce 0.5 to bond order. 11 will be 1.5, 10 already we have done, B2 that is 1. So that is the way you can get the answer fast. But configuration you should be able to write in case bonding, anti-bonding asked. 15 electron system, same way reduced by 0.5. 16 reduced by 0.5. 17 by 0.5. 18 by 0.5, reduce it. 19 by 2.5, 15, 16 to 0.5, 1, sorry. ठीक है, that is the easy way. As I said, our target is to solve all the types of questions which are given in the NCRT or NEET level. So that will work there. If question is about bond order, no need to write the configuration, count the number of electrons in the which part. It will work for the homonuclear diatomic, and in NCRT, whichever ions given, heteroatomic also, as per NCRT, that also we treat like them only. ठीक है, हाँ, below 8 तो we can, below 10 तो we can directly write the configuration, ना? That's the point. Getting it? So below, generally what happens, we can do for C2 given, so we can directly count electrons. Why to write sigma 1s2? It will be time consuming, that's why. ठीक है भाई, आई बात समझ में? ठीक है, अब देखो, अब एग्जाम्पल करते हैं. Suppose first example already given. Other thing is bond order. You can say bond order directly proportional to, or stability directly proportional to bond order. Stability directly proportional to bond order. More is the stability, or reverse I can say. Reverse is better to say. Higher the bond order, higher will be the stability. Inversely proportional to bond length, or directly proportional to bond strength or bond energy. These are the general terms. Bond order directly proportional to stability of the ion or molecule, inversely proportional to bond length, directly proportional to bond enthalpy. ठीक है भाई, यहाँ तक क्लियर? Now applying this general term for the ions, or example like which one? Write down the bond order for N2 plus, N2 minus, O2 plus, O2 minus, O2 2 plus, O2 2 minus, CO, NO. So applying the same concept, no out of the way question I am writing ion. Why? Because not required as per the NEET level, NCRT level, not giving them. Okay. N2 plus how many electrons? 13. 14 means 3. 13 means reduce it by 0.5. 2.5. N2 minus 15. 14 is 3. 15 will be 0.5 less. That is a fast way to write the answer. Otherwise, you can write the configuration also as per nitrogen. O2, O2 plus, which means 15. O2 minus 16 plus 1, 17. ठीक है? 16 is 2, 0.5 less. 1.5. Yes, very good. Good, good, very good. Then O2 2 plus. It is 16 and 2 plus means 2 electrons less, 14. 3 bond order. O2 2 minus 16 plus 2, 18. Fluorine type. CO. Now see, we have only talked about homonuclear diatomic. Take CO is hetero, but here we do not write any configuration. We treat it like electron system just like them, isoelectronic. ठीक है, तो CO is 6 plus 8, 14, 3 bond order. NO15, it is 2.5. Actually, CO plus is more than 3, but that goes beyond the syllabus part. Okay, so I'm not discussing anything which is not working under these conditions. Cn minus 14 system, and hence it is bond order 3. Getting it? So that is how you can try the question. If directly bond order related question is there, apply it directly. ठीक है भाई, आई बात समझ में? Now try this question. Compare the stability of H2 minus, H2 plus and H2. Compare the stability of these ions. Apply firstly bond order. Bond order more, stability is more. Apply that concept. ठीक है, अब देखो completed. Firstly, I'll write the bond order. Bond order H2 minus, how many electrons? 3. Sigma 1s2, sigma star 1s1. Sigma 1s2, sigma star 1s1. How many bonding? 2. How many anti-bonding? 1. 2 minus 1 by 2. 0.5 bond order. Yes. Second, H2 plus 1 means how many electrons? Only 1. Sigma 1s1. 1 by 2, 0.5. Take H2 2 electrons, sigma 1 is 2, already we have done, it is 2 by 2, 1 bond order. That means among them which is most stable? H2 undoubtedly. Because its bond order is more, remaining are its ions bond order less there. Now tell me, between H2 minus and H2 plus, they have same bond order. Bond order is same. So in that case, how to identify which is less stable? Ultimately, other becomes more stable. Or they are of equal stability, H2 minus and H2 plus. Are they equally stable or? Very good, Sajid. Yes, correct it is. Any other student? So here, student, the point is, if bond order is same, then the ion which has more electrons in anti-bonding is less stable. आई बात समझ में? That you can mention here also. If BO is same, then ion with more electrons in anti-bonding is less stable. So H2 minus will be less stable as compared to H2 plus 1. Clear this point? ठीक है? You can mention this part. If you remember, it's good. If you do not know, then you can mention. If bond order same, then more electrons in anti-bonding, less is the stability. Chalo, next part is, okay, any questions for this question? Any point you want to ask? In this question, any point? Other question is, if Hund's rule is violated, then find bond order and magnetic nature of B2. ठीक है, next question. If Hund's rule is violated, then find bond order and magnetic nature of B2. In B2, we know that the configuration is as per case 2. So then MO configuration, molecular orbital electronic configuration, will be sigma 1s2, which I can write here as KK. Sigma 2s2, sigma star 2s2. Then which will come pi 2p x, and then I can write what? 2. Why? Hund's rule violated. That means as per Hund's rule, each orbital of same energy, they should be singly occupied. If this is violated, then what will happen? Either pi 2p x2 or pi 2p y2. आई बात समझ में? Getting it? So bond order remains unaffected. Bonding, anti-bonding cancelled. Bonding, anti-bonding cancelled. Only which is left? Bonding. So bond order remains unchanged. Bond order is 1 still, but now it is become diamagnetic. Now it is diamagnetic. बोलो, आया समझ में यहाँ तक? Till this point clear? Any student doubt? That Hund's rule says each orbital should be singly occupied, which are having the same energy level. अरे भाई बोलो, आया समझ में कि नहीं आया? Question B2. कविता clear? Okay, very good. Other students awake? Any doubts in that? Very good. Zamir, good. Blessy, good. Good. Yes, good. Good. Hari, very good. Shyam. ठीक है. Next question. Try. If sp mixing is not taking place, then bond order and magnetic nature of CO2. If sp mixing not taking place, that means which configuration you will follow? O2 configuration, where sigma 2pz is less in energy than pi 2px, pi 2py. So here you have to write the configuration. Then case 1 followed. Case 1 means O2. Configuration KK sigma 2s2 sigma star 2s2. उसके बाद कितने हो गए? इतने sigma 2p z2. यस, कितने हो गए? 8 2 10. पाई 2p x1 पाई 2p y1 हो गया पूरे. 4 4 8 4 12 हो गया भाई. चलो, bond order same, no change, cancelled. This is 4 by 2 2, and this becomes paramagnetic. Getting it? So in exam that type of question can be reframed. You can check the PYQs. That question was asked also in the previous year paper. You can see. बोलो, यहां तक क्लियर है? Till this point, can I go back to the NCERT book? ठीक है, तो we have done which part? We have done the magnetic nature. H2 completed. You can read still. You can still read that portion. He2 molecule does not exist. Pe2 does not exist. Then Li2 given. Li2 diamagnetic. Li2 molecule known to exist in vapor phase. You will read every line still. ठीक है, you will not skip anything. Whatever done, then you read NCERT, underline what is extra information given. Li2 is stable, has 1 pair electrons, it is existing in the vapor phase. C2, all story we have done, configuration, bond order, diamagnetic, then underline it, detected in which phase given? Vapor phase. Important to note that double bond consists of both pi bonds. Done, we have already done that part. Similar fashion N2 is said. Similar fashion means you have to do the fashion. NCERT has given it up to you. Then N2 completed. O2 configuration is there. O2 bond order is 2. Already we have done. Then here important lines are marked. O2 molecule should be paramagnetic, and it is prediction that is correspond to the experimental observation. So here this theory successfully explains the paramagnetic nature of oxygen. And same way it is given here. N2 we have done. Then 2s2p mixing we have discussed already. Configuration. ठीक है, done. MOT completed. Molecular orbital theory. So when you practice now, you can practice their orbital diagrams which are given like this in the books also. In this manner it is given. Like this is the orbital diagrams given. In NCERT also given that one, which we have discussed partially last lecture. Remember this one, 1s, sigma 1s, sigma star 1s. Remember this type. So that is, if you want, you can practice 1 or 2, keep on filling it, but at least identify if option is given. That is why. If I will write, it's a waste of time. See, I will write it, it's a waste of time. But you can practice at least which one, N2 and O2. Both are different diagram. If given anywhere in the option, suppose given, you should be able to identify. Otherwise, it will take too much space. So in exam also, small portion can be possible, like energy gap where more. Last class we have done na, delta x, delta y. That can be possible. But complete diagram to difficult to ask. Now we can go for the page number 110. Which part will be there now? Dipole moment. Which part we are going to discuss now? That is dipole moment. Just go through this initial portion, read it. ठीक है, page 110, initial portion, read it, then go for next part. Read the portion. We'll talk about the important term then. Completed first paragraph. Chalo. So here what is given initially? That they have given that H2 is non-polar, F2 is non-polar. Which concept we can use? EN difference. When EN difference is not there, then overall it is non-polar. सही है? That is given here, H2 case, whatever. Then what happens in case of heteronuclear, HF, HCl, HBr? EN difference will be there. More is the EN difference, electronegativity difference between the two atoms involved in a which bond? Covalent bond. What will happen? Electron density will be partially tilted or shifted towards more electronegative atom. Then what will happen because of that? Partial charges will be developed. Yes, delta plus, delta minus. So this polarity in the molecule or in a polar covalent bond, we can explain it by which concept? Dipole moment. We can explain by which concept? Dipole moment. Okay. So here what is given? As a result of the polarization, the molecule possesses a property which is termed as dipole moment, which is defined as product of the charge induced, and it is multiplied by the bond length or distance between the, or distance of separation, which is bond length. Suppose HF is given, HCl is given. So what is the charge induced multiplied by the bond length of the atoms which we are discussing. Okay. Then its units are given. Dipole moment expressed in debye units. Conversion factor given. 1 debye is equal to 3.335 10 to the power minus 30 coulomb meter. These terms you can underline. What is the SI unit of dipole moment? In physics also you do that extensively. What's the SI unit of dipole moment? SI unit of dipole moment is very good. 2 students responded. Third student also. Yes. कूलम मीटर इज द SI यूनिट, ठीक है, बट जनरली वी रिप्रेजेंटेड बाई डिबाई, बट SI यूनिट इज कूलम मीटर. 1 डिबाई इज इक्वल टू दिस मच टर्म, but 3.3336 to 10 to the power minus 30 coulomb meter. Then it is given, it's a vector quantity, sign is given here, that's the sign for dipole moment. Then it is from less electronegative to more electronegative element. Okay, when you read this paragraph, you'll get direction of the shifting of the electron density in the molecule node, direction of cross, leave that part, then we can talk about. ठीक है, so ultimately here our next target is dipole moment, which definition part, then important is the examples, that is the key part of the question. ठीक है, no numericals are given anywhere in NCERT or exemplar, so we will not focus on any numerical given, only part will be comparing the polarity of the molecule. ठीक है, so in better is in the next class I'll start new concept, which is dipole moment, and then after dipole moment we will wind it up the chapter by hydrogen bonding. Completed. So today MOT is over. You can try all the questions from the module or previous year questions. Done. In next class we can continue with the dipole moment, or if you want to ask any question from the paper in next class, do the analysis and then you can ask the questions from the paste paper. ठीक है, any point you want to ask now? Any questions? Otherwise class is over. Okay, bye Alexander, bye. Any other point, any other question? Because almost we are going to end the chapter now. Within 2 lectures, 3 lectures, it is over. Okay, bye. ठीक है, done for the day. ठीक है, okay, अल्लाह हाफिज, जमीर, बाय. ठीक है, चलो self do the paper analysis. In next class ask the doubts. Yeah Shyam, yes. ठीक है, चलो, take care, bye bye.